Hi everyone, and welcome to the presentation of the vector synthesis add-on for Vsynth. At the moment it's a work in progress, so everything you're gonna see here might change, but I thought of sharing the actual state of this development. And as you can see, I have already a patch running, and you can also see an actual analog XY display on screen, which is my leader LBO51MA. So before diving into all this new set of modules and starting from scratch, I would like to explain a little bit what's going on in this patch. Okay, so the idea is to use Vsynth to manipulate rasters. In this case, I'm using the polarizer waveform generator to distort the parallel line one. So for example, if I stop modulating it with the Vsynth module, I get only the raster. So when you have the raster, you can change the amount of lines, you can change the refresh rate. So I'm gonna put 1 Hz, so it's gonna go line by line. We can control also an animation here. We have an animation control that's gonna move the lines. We have also the direction. But then the fun part comes when you can start deflecting the beam, right? So with Vsynth module, so in this case, like this. As you can see, I'm receiving a video signal, but whatever comes to the modulation inputs of all inputs in the system is both textures and audio, so I can actually like send a sine wave, I don't know, let's say 60 Hz, and boom, it's also working. So it can distinguish both inputs and work with both, so that's pretty cool. And also, to save some memory and make the system efficient, all these inputs are pre-patched to the first inlet. So whatever is coming to the X modulation at the moment, it's also going to the Y modulation and the brightness modulation. So if, for example, if I connect the brightness outlet of the raster to the actual connection between the oscilloscope and the sound card, I also get the brightness modulation with the circle from the polarizer waveform generator. But if I grab another waveform generator and connect it to the brightness, as you can see now I have the stripes because this oscillator now is making stripes. So I can have different signals to manipulate X, Y, or brightness, but also everything is pre-patched to the original signal coming to the X modulation input. So as you can see, the outlets are quite strange because one cable is carrying X and Y, and another one it's carrying brightness, and another one it's carrying a sync that we are gonna go and see what it does later. So let me start a patch from scratch, right? Okay, so if we have the Vsynth menu in the same location, we can also grab my new vector menu. And first of all, of course, we're gonna need Vsynth render because this system works with Vsynth basically, so it actually needs this render. And then we need something to communicate our new audiovisual modules to our actual oscilloscope. So in this case, we are using the 3-channel output. There's also an 8-channel output, but since in this case I'm only using one oscilloscope controlling X, Y, and brightness, I'm just gonna use this output for now, which is the simplest output. Take into account that we have here a brightness control, so we can turn the brightness completely off directly from the system, and you will have to actually turn the knob from your scope by hand as I'm doing now, because the brightness control from the system, from the computer, is off. So let me see the settings to see if we have everything perfect. Great, so we can turn this on. Let's turn Vsynth render on and unpin the floating window because we are not gonna need it. And let's just connect the raster as we were doing. So let's just grab XY output to the XY input from the 3-channel and turn on the brightness again. Let's calibrate this, and as you can see, the refresh rate is 50 from my raster, so that's why it's kind of flickering. So let's just put 60 here, and that's gonna fix it. And let's increase the volume so we have it like bigger in the screen, and well, we will have to adjust. Yep, there you go, the brightness. So yeah, as you can see, we are already having something in the oscilloscope. So as I was saying, here you can control the amount of lines, and you can even use decimals here. And as you can see, it's not gonna do any beat or increase the speed or anything like that. It's just gonna keep adding lines, just like in Vsynth oscillators. So, and then you have another knob that controls the speed. So you have an animation there to create different effects. You won't use it all the time, in just a few cases, because, like, for example, if you add a lot of lines, you won't notice much the movement. It's gonna look weird. So it's not for all cases, but it's handy to have it there actually for a lot of things. Let's focus again on the modulations to start with, and I'm gonna add again a polarizer and a preview, because this is the most handy module to use in these cases, because you can switch between stripes and radial shapes pretty quickly. And yeah, let's just modulate this a little bit. Let's add more lines. Let's say 80, and you might see some moire patterns. And there we go. We already are displacing the raster with the sine wave. Let's add just a 30. And then we can change, right? Have a different kind of displacements. And since this signal, with what I'm sending to the X modulation, is also going to Y and brightness, I can plug this already to the brightness and have the modulation there. But of course, you can use other kind of signals, so you can send something else to the brightness. And have different Vsynth shapes doing different kind of process to the raster. And if you unplug this new module we added, you go back to the X modulation because it is pre-patched. If you don't want to deal with any kind of brightness modulation, you just don't send anything to the brightness output, and it's just gonna spit a 1. Or you can turn the brightness off and actually change the brightness from the scope per se, like I'm doing now. Okay, let's turn this on again because we will be using the brightness quite a bit. Let's go back to the grid. Well, and hopefully you can see it properly. Actually, let's add also a preview of this scope. This one is pretty handy actually. It's also a floating window, so we can use it there. So as you can see, there is a ringing and the line in the rightest part of the raster, and I want to get rid of that before doing this displacement, so we have a clean edge. So basically, we need to fade out that edge. So there's a very convenient module named edge fade, and it receives the brightness modulation. In this case, since we don't want to use any brightness modulation, I'm just gonna send a signal from max, a 1, to the brightness input of the edge fade module, and then the sync of the raster to the sync input of the edge fade. And the syncs will tell the edge fade where these rasters ends. Scope preview has the outputs too, and they are a pass, so whatever is coming in, it's coming out. There's no process in the middle here, so it's very convenient also. And let's connect the brightness to the output, and from the right we can start cropping, and yeah, we get rid of that pretty easily, and then we can modulate, and that just not gonna be there anymore. Great. And of course that we can also do this process with the same signal that is modulating X and Y. Also, the radial, the circle is going to the 3 channels. So of course that whatever you send to the modulation input is gonna affect the result in the manipulation of the raster. Something I like to do is using a pixelator. So let's plug a pixelator here and let's put a 4, and you get these really nice squares. There you can see them better. And here's with the brightness modulation. So there are several kind of rasters. So this is the first one, but then we have the grid generator, which conveniently makes grids, and these grids can be modulated the same way as we were doing with the standard raster. Great. That's the grid. This is the polygon raster, which generates polygons, but also with like repetitions. So you can change the amount of repetitions of the lines connected by the vertices. And then of course displays, just like we were doing. So yeah, so with simple modules you have a lot of plasticity of the beam. Let's go back to the raster. Now I'm gonna show you the displacement module, but first I'm gonna turn off the beam because I'm gonna patch a little bit first. So the displacement module basically allows us to do translation, X and Y, scale, and rotation, 2D rotation. But also to displace that with signals. I lied, so this module will include connecting just the texture to the input, but for now it's only receiving audio signals. So if we want to transform a video signal to an audio signal, we can do that with another module named text to audio. So we will need the sync here of the raster we are using the displacement with and the new texture we're gonna use. And we have two different outputs of audio signals, simple audio signals, mono signals, a bipolar between -1 and 1, and a polar signal between 0 and 1. You can use both for these inlets. So in this case, I'm gonna use it with the scale. I like it really much. Like if we do XY modulation here, it's gonna be similar to do it here. So the cool thing with the displacement is to actually use the scale. And let's do the polar signal. And we are sending actually this pixelated image. Oops. Yeah. Oh, so I'm sending that. So we need another pixelator here. I'm gonna put 4 and displace more. And we can also send that signal to the brightness here. And yeah. And let's make it a ramp. There you go. So anyway, actually, if we, so I'm not gonna send anything to the brightness. Actually, one cool thing is doing this displacement here, right? So we have the radial waveform generator going to the raster, and we are deflecting it with it, and we have this. And then I'm gonna grab another oscillator and another one of these and send the bipolar signal to X and Y. And then I will have the sine wave that it's coming from this oscillator displacing now the already displaced raster. For example, here we can use the brightness signal to just displace the scale. And we can omit here displacing X and Y. Right? And for example, if you want to do something more complex, we can have this signal going to the brightness, so it's doing the displacement, and we can have another oscillator going to X and also to Y, because the pre-patch system, and we can modulate it there. And instead of doing that, we can change the scale here. And we can actually do this because we have a scale bias module. So we can do something like scale 2 bias -1. Let's do 0.5 and 0.5. And yep. It's actually interesting to use the displacement module because you can do more stuff, like, for example, using, well, not only the brightness for the displacement, like we were doing just now, but we can also use this same signal to do stuff in the rotation. So what I want to do now is to show you the crossfade module. So I'm going to add here the edge fade. Yeah, I don't want any brightness modulation, so I'm just going to add a sig1 here. And just delete the top line and the bottom and the right. We can use the edge fade like a cropper, right? But it's a crop that is working with the brightness, because we can also crop XY. So let me show you that first, because the cropper and the edge fade are pretty much the same, but one just works with XY and it doesn't take into account the brightness. So you won't be able to fix that line in the right, but you will be able to crop, but you will keep seeing that line. So you will have to do this and fade it actually the brightness. So yeah, I'm gonna crop it to the half, and now I'm gonna displace that. Yeah, nice. And then I'm gonna make another figure, with the, let's use the grid generator. And I will use another edge fade to do the opposite. So I'm gonna crop the left. Right? So one thing we can do is to crossfade, and for that we grab the crossfade module. But as you can see, the inputs say X, Y, and B. So that's what I'm saying, to have less cables. So what we can do is grab here the X, Y, B compose, and we just do this. And let's connect the brightness too. And we do the same with the other component of the patch, with the other architecture. So as you can see now, my crossfade is in morph mode, so I can crossfade between the two, kind of morphing the two shapes, right? But also, we can mix them and see them both at the same time. There we go. There we go. My grid was with a incorrect refresh rate. So yeah, so this is pretty cool because we can actually crossfade and have both of them at the same time, or change the brightness of one while increasing the brightness of the other one. And yeah, with the displacement here, I can even like move mine around, and as you can see, they are mixed okay and without any like weird artifact happening. So this is quite powerful, and as you can see, it's really clean in the patch because we have a source, a raster being modulated, then we crop, and then we compose all that, and we do the same with the other one, and then we just mix, and you have like the two shapes, and you don't have to be connecting like X, Y, and Z brightness like all the time. It is just one cable, so it's like really clean for the eyes. Actually, instead of a signal one, using the brightness modulation, which in this case is gonna be the same polarizer, and in the other case it's gonna be well, the pixelated signal. And this is what we get with the brightness modulation uh, working, because before we weren't doing actual brightness modulation, we were just like cropping. In this case, the brightness, before being cropped, it's being modulated by the signal going, in this case, to the brightness input, and um, in this other case to the X input, but remember that the inputs are pre-patched, so they are the same. So the last thing I want to show is the 3D module, because even though like maybe this is something I'm gonna change in the future, let's see, but even though we are seeing this, if I actually use the 3D rotation module, you will see that is 2D. So to do actual this set displacement at the moment, so I'm just gonna plug the brightness here, and as you can see, well, I have here, of course, attenuator for the signal, and yeah, now it's rotating, and as you can see, it's 3D. But I didn't go farther with the 3D, so this is all we got. And well, I mean, there are other modules, like for example, simple effects like the degrader. Um, let's do like this because the preview it's a pass module, so whatever comes in comes out, so it's handy in this case to only connect once. And yeah, after the crossfade, let's do the 3D once again because I want to show you something. Which is, let's do like this, and let's add a pixelator in the mix. There are other cool things to do, like for example, we can do a pretty crazy video feedback thing with Vsynth and visualize this in the raster, which creates really, really nice results. I want to show you that. So let's just add these really simple modules. Just gonna add it really quick. I don't even gonna explain this part. I might actually fast forward the video. Okay, there we go. As you can see, now we are visualizing some Vsynth feedback on the raster, and it looks really great. I'm gonna put a preview so you can see what it's coming out from Vsynth. Well, I mean, you are seeing it in the raster because it looks really great. It looks exactly the same. Of course, we can use it to displace it a little bit, which is fantastic. And another thing you can do, for example, you want to do radial mask. Basically, what you have to do, if you want that, is grab a polarizer so we can wave shape that square a little bit more, make it nicer. Yeah, that's what I'm talking about. No, not the bias. Yeah, the bias. Great, so there's my circle there, and I now want to multiply this feedback with the circle and send that to the brightness. And yeah, there we go. Amazing. There we go. There you can see it like really well. Yeah, there we go.